Hello everyone, this is my sixth video in this topic, that is balancing redox reactions by ion-electron method. So let's see what is example number 6. Here the reaction is phosphorus reacting with NaOH and water, giving pH 3 and NaH2 PO2. Sorry. So as you can see here, sodium hydroxide is present in the medium. So the reaction is in alkaline medium or a basic medium. As I said in my last video, that for balancing in the alkaline medium we cannot use any H plus ion. Here we have to use only OH minus ions and water molecule. So first write it in ionic form. Actually not much to write here in the ionic form, because phosphorus is giving the two species, that is pH 3 and H2PO2 minus, because Na plus and H2PO2 minus. pH 3 should be written as it is because pH 3 is a covalent molecule. So we cannot write it as ionic form. So this is the ionic form of the main changes. This is actually a special type of reaction, because you see here phosphorus is in 0 state, here it is in -3 state, and here 2 oxygen means 4 negative and 2 hydrogen means 2 positive. So 2 negative ions is the resultant, but 1 negative is there, so phosphorus is giving +1, that is phosphorus in +1 state. So 0 oxidation state is going to a lower oxidation state, that is -3, and a higher oxidation state, that is +1. So this is this type of reaction where one oxidation state is dissociated to a 2 different oxidation state is called disproportion oxidation reaction, redox reaction. In my earlier one of the examples that I showed one comproportionation reaction. Anyway, this is not my topic today. I will make maybe one video about disproportionation and comproportionation redox reaction. Okay, so let's balance this reaction. One change, for the first change is phosphorus is going to pH 3. Here phosphorus is balanced because one phosphorus, but 3 hydrogens are extra in the right hand side. For balancing hydrogen atoms, we will add the equal number of OH minus ions in that side where hydrogens are extra, means 3 hydrogens are there, so we will add 3 OH minus ions. Okay, so now we are getting 3 and 3 means 6 hydrogen and 3 oxygen. So if we write here 3 H2O, that will balance all the atoms. Okay, now balance the charge. Here 3 negative ions are there, but no charge in the left hand side. So if we add 3 electrons here, that will balance everything, means charge and atoms. Okay, this is the first process, and the second process is phosphorus is going to H2PO2 minus. Phosphorus is going to H2PO2 minus. Okay, one phosphorus is balanced. 2 oxygen atoms and 2 hydrogens are extra in the right hand side. Let's first balance the oxygen atoms and forget about hydrogen. We'll take care of it later. Now for balancing oxygen atoms, the side at which the oxygen atoms are extra, we will add the equal number of water molecules. Here 2 oxygen atoms are there, so we will add 2 H2O. Okay, now we are getting 4 hydrogen and 4 oxygen. So if we add 4 OH minus ions, that will balance the oxygen atoms, but 2 hydrogens are extra already there. So now we have to take care about the hydrogen. For balancing hydrogen, what we will do in the first process, I have already showed that the side at which the hydrogens are extra, you add the equal number of OH minus ion. So here 2 hydrogens are extra, so we will add 2 OH minus ions. Okay, now we are getting 2 hydrogen, and 2 hydrogen means 4 hydrogen and 2 oxygen, so we can add 2 water molecules here. Okay, so overall what we are getting, you see, 2 water molecules and 2 water molecules, so it will be cancelled out, and in the left hand side 4 hydroxide ions are there, and here 2 hydroxide ions are there. So resultant reaction will be phosphorus plus 2 OH minus going to H2PO2 minus. Okay, see, 1 phosphorus, 2 hydrogen, 2 hydrogen, 2 oxygen, 2 oxygen. So atoms are balanced. Now look at the charge. Here 2 negative ions are there, and here 1 negative charge is there. So we have to make the left hand side 1 negative charge only. For that we will subtract 1 electron. Okay, this is the 2 balanced half reaction. Now we have to assign which one is oxidation and which one is reduction. Here the electrons are added in the left hand side, so it will be reduction half reaction, and this will be the oxidation half reaction. Let's wipe out the in between what we did for the balancing. This is not required now. Okay, so it will be the oxidation half reaction, because electrons are subtracted at the left hand side. Okay, now we have got the 2 half reactions. Now our task is to combine these 2 reactions to get the overall balanced redox reaction. Okay, for that what we will do, we will first write it as number 1 and this one is number 2. Okay, now what we will do, we will multiply this reaction with the coefficient number of the electron. Here means here it is 1 and here it is 3. So if we multiply reaction number 1 with 1 and the reaction number 2 with 3, this will give the equal number of electrons in both the reaction, and when we will combine, this will be cancelled out. Okay, so number 1 into 1 plus number 2 into 3. Okay, so P plus 3 H2O plus 3 electron giving PH3 plus 3 OH minus, and the second reaction will be multiplied by 3, so it will be 3P plus 6 OH minus minus 3 electron giving 3 H2PO2 minus. Okay, now add them. This will be cancelled out, so we will have 4P plus 3H2O, and you see for OH minus ions here 6 OH minus, and in the right hand side 3 OH minus ions are there, so resultant will be 3 OH minus ions in the left hand side, so we will write 3 OH minus only. And now in the right hand side we are getting 1 PH3 and 3 H2PO2 minus. Okay, this is the balanced redox reaction in the ionic form. Now we have to convert it in the molecular form as the reaction is given in the molecular form. For that we will need this space. Okay, so P was there, so if we write it in 4P, that will be okay, no problem. Now water will come later. 3OH minus, OH minus is coming from NaOH, so it will be 3NaOH plus water is 3, so 3 water molecule giving pH 3 and 3H2PO2 minus. H2PO2 minus was coming from NaH2PO2, so it will be 3NaH2PO2. Okay, this is in the molecular form, but you should check one more time whether everything is okay or not. Now you see 4 phosphorus, here 1 phosphorus, and in the NaH2PO2 there are 3 molecules, so 3 phosphorus, total 4 phosphorus in the right hand side, and which is balanced with the left hand side 4 phosphorus. Now sodium, 3 sodium and hydrogen. Let's take the hydrogen, 3 hydrogen and 6 hydrogen means 9 hydrogen. Here you see 3 hydrogen and 6, so overall 9 hydrogens. And the oxygen, 3 oxygen and 3 oxygen means 6 oxygens are there. 3 into 2 means 6 oxygens are in the right hand side as well. So everything is balanced. When you are satisfied, you just remove this arrow sign and place equal sign. This is the balanced redox reaction of the given reaction. That's all for this. I will make more videos about in this topic. So if you are interested, or especially if you are a student, you can subscribe my channel to get this type of videos more. And thank you all for watching my videos.